Okay, let's start with example 2. Same method. Set up the x. Top part is the product of leading coefficient positive 5 and the constant negative 6. So 5 times negative 6. That's equal to negative 30. Drop the second coefficient plus 13 at the bottom part. Two numbers that multiply together to give us back negative 30, but also added together to give us back positive 13. I would say negative 2 and positive 15. Is that true? Well, negative 2 times positive 15 is negative 30. Negative 2 plus 15 equals to positive 13. So there we go, we have it. So this expression can be written as, oops, I don't know why I said that. Keeping the 5x squared, subtract 2 from here, but now it is multiplying the x, plus positive 15, also multiplying the x, and then keep the minus 6. 1 term, 2 terms, 3 terms, 4 terms. Group them together, thinking of the sign in the middle as separating these two, the first and the second, and the third and fourth terms. Well, let's see, for the first binomial, we cannot factor out any of the coefficient because the smallest coefficient, negative 2, is a factor of itself, but not of positive 5. So we have to leave it alone, but we can factor out the x. So factor out the x, we're left with 5. Yeah, we're left with 5x minus 2. What about for the second one? Well, let's see. For the second one, well, we know that 15 is the same as positive 3 times, positive 3 times 5, not 2. Let's see, negative 6. Negative 6 is the same as negative 1 times 2 times 3. Well, hey, guess what? We have a common factor of positive 3, so we bring it out. So we got plus 3 multiplied by the leftover. Well, the leftover is just going to be 5 times x. For the second term, the leftover is going to be negative 1 times positive 2, so that's minus 2. But hey, guess what? A common term, a common binomial, 5x minus 2, factor it out. And then we're left with just x plus 3. This is the factor form of example 2.